Hello, everybody. Welcome back. This is our third video. It's called Quadratic Equations. Now, this is something I know that y'all have seen before. You've seen it, in Algebra 1. You've seen it again in Algebra 2. You've seen it again in a little bit in geometry, not as much in geometry, but definitely in Algebra 1 and Algebra 2. So this is more or less kind of like a review on quadratic equations, mainly how to factor them. Okay, so let's look at what we're going to cover here. I know it looks like a lot. Um, so we're going to look at basically just factoring. Then there's going to be a specific property that we're going to talk about. Then looking at completing the square. Now that one might be the new one for you because I'm not sure if you've done completing the square in the past. Quadratic formula, hopefully everybody knows. And then we're going to talk about the discriminant. And then looking at, the last two, the most effective method, and then problems modeled by quadratic equations. So basically, the last dot is your word problems. It's just going to go in and you're going to plot your quadratic and read the answer that way. And that second to last dot, it's basically you're going to take these ones here, right here. You're going to take those and you are going to decide which one is the best way. Oh, maybe not that last one. But which one the best way for you to be able to solve these problems is going to wind up being. So it's really these four right here. Okay. So let's jump right into this. First off, let's start off with, well, what is a quadratic equation? Basically, when we start talking about a quadratic equation is when you basically have an x squared term. X squared plus bx plus c is equal to 0. Basically, when we're dealing with that, however, honestly, it doesn't matter if these two, your b and your c values, are 0 or not, because they can be. So that's okay. You can have 4x squared equals 0. That's absolutely okay. But the key thing is on this one is that you want to make sure that your a value here, your a value can never, ever, 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 ever equal 0. Because if it equals 0, you don't have an x squared term, and so therefore you don't have a quadratic. So you have to have an x squared term, and it has to be the highest or the highest exponent in order for you to have a quadratic. Okay. A quadratic with an equation in x is also called a second degree polynomial. And we'll talk about more what that means when we actually get to polynomials, but just know that quadratic equations are called second degree equations. So what exactly are we going to want to be doing? Well, we're going to be factoring. And what we're going to be doing is we want to be able to have what a zero product rule is. So what I'm looking for is, in simpler terms, is where does this graph cross the x-axis? That's what this whole entire thing means, is where do I cross the x-axis? And wherever I cross at, that is where my zero product or my answer is going to wind up being. So this piece right here. And, just because everybody should know this, if you have a times b equals 0, then either a or b or both is 0. So that's all this is really saying here. When you multiply two numbers together, you get 0. To solve a quadratic equation by factoring, you're going to apply the zero product principle, because if you think about this, when you factor, you get ax plus c, and then ax plus d. When you take these here and you multiply them together and you have them set equal to 0 here, what it's saying is this times this, one of these needs to be equal to 0 in order for this whole entire thing to be a true statement. Okay, so let's go. Let's keep going right there. How do we factor? All right. Well, we'll solve a quadratic equation. The first thing that you need to do is you need to move everything to one side. Now, typically, we move everything to the left side. That's just how we've been taught. If you don't like the left side for whatever reason, that's okay because you can pick any side that you want in order to be able to solve these equations. Once you move everything to one side, then you're just going to factor. That's all you're going to do is just going to factor. Now, on step 2, on this one right here, I'm going to show you a couple of different ways on how we're going to actually factor these problems, okay? And then you're going to be able to choose the one that you want so that you'll be able to factor them completely. Step 3 is basically saying, okay, so once you factor, you want to get this set up into this position here. So step 3 says, all right, once you factor it completely, hopefully you've got something that looks like this, because that's what you want. Because then what's going to happen in step 4 is you're going to take that first one and set it equal to 0, and you're going to take that second one and set it equal to 0. And then step 5, again, just like with linear, you're going to be able to check your equations. And so when you check your equations, you can literally go back to step 3 right here, plug either one of your answers in, and if this goes to 0, that's going to be a correct answer. And if this goes to 0, that's going to be a correct answer. Because remember, in a quadratic, you can have one answer or one unique answer, or you can have two unique answers to make this piece here equal 0. Okay? Oops, I didn't do that. All right, so let's take a look at this. So we're going to solve this first one by factoring. All right. You have been taught over the years a bunch of different ways to factor. I am not here to force you to learn a new way. I am here to show you, either refresh your memory on the way of doing it, or maybe I show you something different. It's completely up to you on how you want to do it. I'm going to show you how I do it, and if it works for you, great. If it doesn't, because you like a different way, great as well. So the first thing that we have to do is we have to take this 2x squared plus x equals 1. We have to move that 1 over to this side. We can't do anything until that happens. So I've got 2x squared plus x minus 1 is equal to 0. All right, so now I've got that 2 right here. So I can't do my traditional easy factoring where I can just say like the factors of 1 that subtract to give me 1. I can't do that because I have an actual a value that's not 1. So what I do, and again, everybody's been taught differently, but I do this little t-chart here, and this is how it sets up. This will be a times c. This is sine of c. And this is my b value. And then the answer to these 3 here go right here. So let's take a look here. Oops, one too many. So you have to remember, here's a. Remember, there's an imaginary 1 there that you don't see. That's your b, and this is your c. So remember, a times c goes here. A times c is -2. My sine of c is a negative, so this is sine of c. And then down here, this is my b value, which is going to be a plus 1. So I need factors of -2 that subtract to give me a positive 1. So I know the only factors of 2 that I have is a 2 and a 1. These are the only ones I have. But in order to get a positive 1, that means my negative has to go here. Because when I multiply -1 times 2, I get -2. That works out. And then when I add these two together, I get a plus 1, so that works out. All right. So now that you're here, what we're going to do is we are going to take these, and instead of writing plus 1x, I'm going to change that plus 1x to 2x minus 1x. I'm just going to change the clothing is all I'm doing. So what that looks like is this. I'm going to keep my 2x squared. Now, instead of writing 1x, I'm going to write right here. I'm going to use this right here. I'm going to say plus 2x minus 1x. And then keep my minus 1, and that equals 0. And then you have to remember that this piece right here That is my 1x. So I didn't change the integrity of the problem. Now I'm going to split this in half. Boom. I'm going to factor this piece up here. So what we're doing is called factor by grouping. So I'm going to ask myself, what does 2x squared plus 2x have in common? They have a 2x in common. 2x goes into 2x squared x times. 2x goes into 2x one time. And then I'm done with the front. So now I'm going to look at the back. Now, the key for the back is this is what you want to wind up with inside your parentheses. So again, you're going to develop new parentheses. I'm going to say, what does negative 1x minus 1 have in common? Well, just a simple negative 1. And that leaves me with x and then a plus 1. So you will notice now that this one here and this one here matches exactly. So now what I'm going to do is I'm going to pull out what they have in common, which is my x plus 1. And then I'm going to combine my leftovers. All right. So now this is completely factored for us. But we're not done because the key word here is solve. So when it says solve, we have one more step to do. So I need to take this set of parentheses, x plus 1, and set that equal to 0. And then I take this set of parentheses, 2x minus 1, and set that equal to 0. And then I'm going to solve both of these equations. So this is simple, a one-step equation. I'm going to move that plus 1 to the other side, so I wind up with x is equal to negative 1. Over here, I have a two-step equation. So I'll move that 1 over, so I get 2x is equal to 1. Divide by the 2, so I get x is equal to 1/2. So the answer to this equation is is negative 1 and 1/2. So that's where, if I was to draw this parabola out, I would be able to look at this and look at where it crosses, oops, I pressed the wrong button, where it crosses the x-axis, and it will cross here and here. So this is something that you've been doing since the 9th grade. So again, you're probably taught a different way, and that's a-okay. If you like this way, then that's fine as well. But when it asks you to solve, that's simply what it's asking you to do. Is just tell me where this equation is going to equal 0 at. So where does my y value go to 0? All right, let's move on. Ooh. So now what we're going to do here is we're going to look at what's called the square root property. So the square root property says this. If you have an equation in the form of u squared equals d, then this happens. When you solve for u squared, you get u is equal to square root of d, and u is equal to the negative square root of d. So remember, you have two specific answers. So if I said u is equal to the square root of 9, that means u is going to be, well, what's the square root of 9? 3. But also, it's going to be negative 3, because negative 3 times negative 3 will give you a positive 9. So you're always going to have two answers. The key thing here is when you're looking at this value right here, this is your principal value. That's normally when they ask for the principal value, they want to know what's the positive value. And your positive value is going to be whatever this first piece is here. But if it says that what are my solutions, you have two solutions that you have to deal with, and that's going to be this one and this one. The vice versa is true. So if I give you this one, the square root sign, if I square both sides, you have the negative d, the negative square root of d. When I square that, I wind up with u squared is equal to d. But remember, there's always going to be two answers to it, okay? So just keep that in mind when we do this. So we want to do this by completing the square root property. So the first thing that we want to do is this. We're going to come over here and say, okay, I have a square root property. So this is the only exception to the rule. When it says square root property, it wants you to put it into this form here, okay? That's what it wants you to do. It wants you to do that. So we have to come over here to this problem here, and we have to move that 45 over here. So what I'm going to do is I'm going to move the 45 over, so I get 5x squared is equal to negative 45. I need to be in this form here. So I'm going to divide both sides by that 5, and I get x squared is equal to negative 9. Now, now that I'm here, I need to go from the x squared is equal to d to the x is equal to plus minus the square root of d. So I'm going to take the square root of both sides. I get x is equal to the square root of negative 9. But remember, you can't have a negative. So what we're going to do is we're going to say, okay, well, don't forget the plus minus. We know that this is going to be plus minus I square root of 9. Well, what is the square root of 9? So x is equal to plus minus 3i. And that is your answer. And if you was to graph this, you're going to get something that looks like that. It's not going to touch the x-axis. It's not going to cross the x-axis at all. That is why we have an I value there, because this quadratic did not cross the x-axis. Now, depending on the question, does this have a solution? It does not in the real number world. Okay, remember, this is an imaginary number. This is a complex number. So yes, it has a solution, just not in the real world. So pay attention to what the question is asking. Do you have a solution? Well, I did get a solution. I did get plus minus 3i. So yes, those are solutions. But just remember, if it's asking for the real number, if it says real numbers, then your answer is going to be does not exist. Okay. If this is a multiple choice question, and let's say A said 3i, B said negative 3i, C said the square root of negative 9, and D said plus minus, no, it doesn't, not that one. Let's say, oops, negative 9, and D said negative 3i, comma, 3i, your answer would be D. Even though all these three answers are correct, you have two answers. You have a plus answer and a minus answer, so you have to pick the one that has both answers. All right, next slide. Completing the square. Now, this one I'm pretty sure is new to a lot of you. It's just something that's just not done. So what happens when we complete the square is we are going to take our quadratic, especially if it's not factorable in that form, and we're going to move the c value over to the right hand side, and then we're going to do this piece here, because what we want to do is we want to be able to complete that square. And once we do that, this side over here should result in a perfect square. And so that way, when we go through the problem, we have this perfect square, then we'll use the square root property to solve. So let me show you what that looks like, because I know that sounds kind of like I have no idea what you just said. So we're going to look at this one. So if I give you this problem and I say, okay, x squared plus 4x minus 1 is equal to 0, what's that answer? Well, there are no factors of 1 that subtract to give me a positive 4. So we can't factor this normally. So what we want to do, one of the ways that you can do this is by completing the square. So the first thing you want to do is move. So step 1 is move the c value. Okay. So we're going to move the c value. So we wind up with x squared plus 4x is equal to 1. That's the first thing. So then what we're going to do is we're going to say, okay, what I want to do is I want to say on number 2, Go back one. I want to take our b value and I want to divide that by 2 and then I want to square it. But remember, what you do to one side, you have to do to the other. So I want to do this for step 2. So my b value is a 4 and I'm going to divide that by a 2 and then I'm going to square it and I get a 4. So I wind up with x squared plus 4x and then plus 4. But remember, what you do to one side, you have to do to the other. So you have to maintain that balance. Step 3. Now we want to factor the left side. So this becomes now a perfect trinomial. So this factors down into x plus 2 squared is equal to 5. Step 4, we want to square root both sides. So I'm going to take the square root of this side and the square root of this side because I'm trying to get rid of that squared right there. Oops. And so when I do that, I wind up with x plus 2 is equal to the square root of 5. And then step 5 is solve for x. I'm going to kick that 2 over. Now remember, I took the square root, so this is a plus minus. So I have plus minus the square root of 5 minus 2. And that is your answer. Plus minus square root of 5 minus 2. Now, when you complete the square, the key thing is there cannot be anything right there. There has to be that 1. If there's a 2, a 4, a 1/2, anything there, you cannot complete this square. All right. Keep that in mind. You have to have a 1 sitting there. You cannot, under any circumstances, have any number sitting there. You can, but you have to divide every single term by that lead coefficient. And that gets kind of ugly because then you wind up with fractions. So if you ever see that, then try a different method. If that method is just not working for you, then you're going to need to go back and then try to complete the square that way. Okay? Let's move on. So this one here, the quadratic formula, this works for, I can't stress this enough, everything. All right, so this one formula here. If you want to always get the correct answer, you want to use that. Now you're sitting there saying, well, shoot, then why don't we just use it all the time? Well, the problem is if you use it all the time, it takes a lot longer in some cases because there's some of them you just look at them and do it. You might be quicker at completing the square. You might be quicker at, the square root method might work better. There just might be better options. But if you want something that 100% is going to work 100% of the time, that would be the quadratic formula. So if you ever get to a point to where you can't factor something or you're stuck, just go to the quadratic formula. So if I've got this, 2x squared plus 2x minus 1, that's my A, this is my B, this is my C. Remember, x equals negative B plus minus the square root of B squared minus 4 times A times C, the whole thing all over 2A. All you're going to do now is that we know that my A equals 2, my B equals 2, and my C equals negative 1 for this problem. It is now simply a plug and chug. Now, if you put this into a calculator, you will not get an exact answer because it will take the square root back here and it will put it in decimal form. So if you're trying to use a calculator on this and you wind up with an answer like 2 plus minus the square root of 3 over 4, you won't get that specific answer. You're going to get the decimal equivalent to that. So you need to make sure that if it's got exact answers that you're not putting into the calculator, because it won't give it to you. Now you can take pieces of it, like you can put this piece into the calculator and get an answer. And then you can put this into the calculator and that in the calculator and then put everything back together. That's okay. But in terms of sticking the whole thing in, unless your calculator has a cast system, it's just not going to work for you. So let's plug all this in. So I have x equals negative b, that's negative 2, plus minus the square root of b squared minus 4 times a times c all over 2 times a. Oop. I did not write that right, did I? Oh, one too many. Negative 1 all over 2 times a, not c. My bad. All right, let's clean this up. Now it's time to do some math. Negative 2 plus minus a square root of 4. And then we have a minus 4 times 2 is negative 8 times negative 1. That's a plus 8 all over 4. Then we wind up with negative 2 plus minus the square root of 12 all over 4. Now, this will not be a multiple choice answer. You're probably saying, well, why not? Because sitting right here, you have to take that and you have to simplify that square root. So you have to pull out that perfect square and then make this square root a more simplified square root. So we need to come over here and say, okay, well, I have the square root of 12. What are my factors of 12? We have 1 times 12, 2 times 6, 3 times 4. The only one with a perfect square in it is going to be that one. So what I'm looking at here is I'm really looking at 4 times 3. Well, what's the square root of 4? That breaks it down to 2. What's the square root of 3? We have no idea and don't care. So what we're going to do now is come over here and say, okay, negative 2 plus or minus 2 square roots of 3 all over 4. Now, we are going to cover up this piece here for a second and only look at the negative 2 plus minus 2 and the 4. They all have a 2 in common. So then we're going to say, okay, well, got to simplify this even more. So I get a negative 1 plus or minus 1 all over 2. Well, don't forget that you have that bad boy sitting right there. So we need to get rid of that and bring that square root, that square root of 3 back. And that is your final answer. Okay, so when you go through this problem, even though you are here and you got an answer, it is not going to be your multiple choice answer. This here is going to be your multiple choice answer. Probably not with that one. It's probably going to look like that. And the reason being is because you can take that 12 and do this piece right here to simplify that 12 down to turn it into 2 square roots of 3. So make sure if you get to an answer and you're looking at your multiple choice answers and it's that there, that means you're going to have to take your square root and break it down. And remember, you're always looking for the biggest square root that's hiding in the factors, okay? So let's go to our next problem then. The discriminant. So now that you've talked about the quadratic equation, in the quadratic equation, there is this thing here called the discriminant. And the discriminant is this piece right here. the b squared minus 4ac. What that does is that tells you if I only focus on this piece right here, it's going to tell me exactly how many types of solutions I have. So let's look at what that means. If I have negative b plus, no, I lied to you. Let's try that again. I was trying to write the quadratic equation, and we don't want that. If I've got b squared minus 4ac, if this is greater than 0, you will have two unique answers. And sorry about the dog barking in the back. He's mad because I got the door shut. If I give you b squared minus 4ac and it equals 0, you have one, I guess, unique answer. If you have b squared minus 4ac and it is less than 0, you have two imaginary answers. Okay, so those are the three things. And just to give you a quick idea, just a quick sketch, if I've got this one, my graph is going to cross the x-axis twice. If I've got this one, my graph is going to sit on the x-axis. And if I have this one, my graph will not touch the x-axis at all. So if you're looking at the graph and you're trying to determine how many answers are all based off the graph, that's the other way you can look at it as well. So if you're not quite sure, if you're trying to verify that you've done something right, throw it into the calculator real quick and graph it and see how many times it crosses. But these are the only three options that you're going to wind up having on this, which I just said that. So now we're just going to compute the discriminant and figure out how many types of solution this problem is going to have. So remember, our discriminant is b squared minus 4ac. Remember, this is a, this is b, and this is c. And mind you, in case you forgot, numbers only. Don't care about the letters. So b squared is negative 7 squared minus 4 times 2 times negative 4. 7 squared is 49. Minus 4 times 2 is negative 8 times a negative 4. That is a positive 32. And then I've got 49 plus 32 gives me an 81. So I'm going to have two answers or solutions to this problem. Okay, so I have two real solutions for this one because I got a number that's bigger than 0. All right, questions on that? Well, hopefully not. If there are questions, hopefully you're emailing me or asking me for a reminder, whatever. So going through everything that we just talked about, we looked at different ways of factoring. You can factor like you've been taught. You can use completing the square. You can use the quadratic formula. You get to choose, for the most part, how you're going to do it. Now, on your test, when it gets time for the test or whatever, they're going to tell you specifics, and so you might have to plug in specific things. So just be aware of that. So if they tell you specifically, I need you to complete the square, or I need you to use the quadratic formula for this, then you have to follow those steps. So please don't neglect, one step because you like the other one better. Make sure that you're getting an equal practice in the both steps or whatever. In the word problems, again, just read the word problems and follow the instructions or whatever. They're going to give you the formula or the equations, so you'll have to go through there and just plug that in and base your answer off of that, okay? Don't forget, if you have any questions, please make sure you are sending me emails. Please make sure you are sending me text messages on Remind. If you are in the middle of a homework question and are stuck, hit the Ask Your Instructor button. Just make sure that you're emailing the Paris email, so that way I'm aware of it. I will check my PJC email. I just may not check it in enough time for you. So if it's urgent and you're trying to get this done and you desperately need to get my attention, that's the quickest way. I will eventually check it. I will only check it probably during my conference period. So just be aware that, so if you are doing homework at 10 o'clock at night and you need me to check something right away, hit that Ask the Instructor button, and then make sure you are emailing me as well. So that is it for quadratic equations. What you're going to do now is log into Blackboard, and you are going to go to the quadratic equations homework, which is, I think, 1-5. And you're going to go through there and you're going to do your problems on that. So I will see you and talk to you when I do. TTFN. Ta-ta for now.